Hi, everybody. My name is Marie. Let me stop this share for a sec. Well, no, I'll keep going. Okay. My name is Marie Bursick. I am a GRE and GMAT tutor for Leland. I think I would probably say that I specialize in quant. I used to be a high school math teacher. I always did SAT and GRE tutoring on the side. And then for the past 8 years, I've been doing GMAT and GRE full time. Really primarily getting people ready for business school. I wanted to give you guys a lesson, my kind of a little sample of what I do in my first lesson to give you guys an idea of what test prep looks like. And sometimes people want to know what it's about, like what's the magic, what is the secret sauce that makes working with a tutor different than doing some sort of self-guided study. And I do have a lot of students who work with a self-guided course. You know, there's some that I definitely think are better than others, and some very intense courses, that maybe, I think that what happens is sometimes people don't know what to prioritize, what they need to really memorize, and I sort of like help organize all of that for you. So before we even begin, I would like to just sort of take a poll from you guys. If you could put in the chat, let me know which test you are preparing for and which round you are preparing for. If it is deferred enrollment, I don't know if I have any seniors here, or what else what test you're looking for. Okay, cool. Just please let me, that just gives me an idea of like, who I'm talking to. Okay, round one. I have some people who are still doing round two. Okay, so, okay. And yeah, and just again, to repeat, I'm gonna say like, let me know when you plan on applying. Are you applying for round one of 2025? Are you doing deferred? That kind of thing. Okay, so before I start the lesson, I'm just going to tell you a little bit about myself. I usually do this at the end, but I feel like I don't know how many people are going to stay to the end. And I should probably get a little bit of like how I work and how you can see, if you want to make like an educated decision about who you're going to work with. And I think I want to just explain to you what I think is good practice so that you have an idea of what it should look like. Okay, so this is how I create files for my students. I think that when I work with students, I have like the math concepts that I have to get through with my students. I keep like this list on the side. And then in my lessons, I think that one thing that my students like is that I'm very, very structured, and I give people, I try not to put like last names here so that, I can share this stuff, but I just started working with a student who is getting ready for round two. And we did a little bit of like the lesson we're doing today. And then what I do is I think what people like is that my homework is very like step one, step two, step three, and it's very checklist. Other things that I would like to, let me bring this up, show you guys is that I have with my students, I also create worksheet trackers or study plans so that like I can go through worksheets with them. This is a student who just finished. You might see her review. She left a review a couple days ago. It went really well. She got a 705 on the Focus edition. So I'm kind of definitely really proud of that. It went really, so basically she came to me just for quant help because she was kind of ready for her other subjects in the Focus edition. Okay, so and then yes, and you can see a little bit about how I organize myself, and I have when I work with my students, different things that I do is I invite them into this drive, and I also have different lessons that are lots of different lessons, basically, that, this is how I set myself up, a little bit of my curriculum. Okay, so let me jump back into my first day lesson. Okay, this is a lesson on integer properties and something that I call number caterpillars. So, and the other thing I'm going to ask is, I'm not sure if there are any problems. Last time I had some problems with my Wi-Fi connection. If that happens, can someone just jump in and flag it and let me know, because it's going to be on your end and not mine, and I'll turn the camera off. So what I would like you guys to do is to start off, I would like you to write the first 10 prime numbers. Write the first 10 prime numbers, and then, let me wait for everyone to catch up. And while you guys are working, again, let me speak that what I'm doing is my first day lesson on integer properties, this concept that I call number caterpillars. We're going to go through greatest common factor, lowest common multiple, and I'm going to show you, hopefully, I think it's like a new way to look at numbers, and to do some of the first, I always start with this lesson because this is how I think of numbers, and this is something that's like interlaced into all the content that I teach. All right, prime numbers are indivisible. So 2 is the first prime number. It's the only even prime number. And we're going to go 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. These are the first 10 in existence. 2 is the only even prime number. Okay, prime numbers are numbers that cannot be broken down. They cannot be factored any further. I think of them like elements on the periodic table. And so this idea of number caterpillars, let me explain why I call them this. I think of numbers like 12. When you do a factor tree for 12, that's 2 times 6, and 6 breaks down to 2 times 3. So 12 is 2 times 2 times 3. And before I called them number caterpillars, when I was teaching SAT for many years, I used to think of them as number molecules. And I would say, how like H2O is an oxygen and 2 hydrogens? Well, 12 is 2 2s and a 3. And I explained it like this for a while. Then I taught middle school, and it took on a new form, and I called them number caterpillars like this. So it's something that I would say when I say caterpillar number, I mean write the prime factorization of it. And again, the idea is that these are numbers that cannot be broken down any further. So sometimes people will think 1 is a prime number, and I want to explain why 1 is not a prime number. 1 is what I say is like the empty set of prime numbers, or it's like when you have no prime numbers. Okay. And what I mean by that is there is a fundamental theorem of arithmetic that states that every integer has a unique makeup of prime numbers. So that 12 is 2 2s and a 3. And if you have 2 2s and a 3, that makes 12. That they go back and forward like that, and it's unique to 12. 1 can't be a prime number because I could put a 1 here, another 1, and it's still 12. I don't know how many 1s to put. So that's why 1 doesn't really count. Another thing that sometimes when I ask people like what prime numbers are, and no one really can define them, but a lot of times people will say they're divisible only by themselves and 1. And that's true. So all prime numbers have exactly 2 factors. Like 13 is 1 and 13. And 1 is different because 1 only has 1 factor itself. So that's another kind of, how I'm proving that 1 is not a prime number. Okay, so this idea of caterpillars, we're going to do this. Please do this for 18 and 30. And I'm going to look over at your responses. If you have any questions, please drop them in. $18 is 2 times 3 times 3. 30 is 2 times 3 times 5. And what I'm going to do is I'm going to color code these. And I make this project for everyone to do in the beginning, between my first and second lesson. It might seem a little silly, but it gets really, really hard. Or this entire concept is one of the hardest. I think that a lot of people will say integer properties and probability are their hardest, and they're kind of closely related. So what I have students do is I make them do the prime factorization of every number between 2 and 100. And I have a website, a game that I have students play sometimes to get better at division using all the numbers under 100. But This is what the project looks like when it's done. Okay, this is one of my students did this on her iPad, and I use it all the time just to reference it. Okay, so as you can see, like she picked a color for 2 and all the 2s are the same color. She picked a color for 3, all the 3s the same, so on and so forth. I'm going to explain a little bit more when we go into divisibility rules. But this is, caterpillaring all the numbers between 2 and 100. Every student has to do this between my first and second lesson. And I give you you're going to learn some tricks on how to break down numbers and make sure that they're all right. In theory, just so you know, not in theory, but there are, this is a person who had unlimited colors. There are 25 different colors because there's 25 prime numbers under 100. So 97 is the 25th color. People don't have if someone gets colored pencils, I usually just tell them to get a pack of 12, because after you get to say 47 is the 15th color, but you're only using this color twice. You're going to use it in 47, use it in 94. I do ask people to do this though, because there are very complicated problems that deal with things like 100 factorial, meaning 100 times 99, all these beads put together, all these circles. This metaphor changes. I will change it to colored beads and beaded necklaces and earrings and all these different things. But there are very complicated problems that deal with like 100 factorial, which is 100 times, 99 times 98, going through all of these and asking like how many 2s would be in the entire chain. And that's why sometimes I need this to explain it. Anyway, and it's a lot more, it goes into many more layers than that, but I don't want to get ahead of myself. Okay, so first I'm just going to start by showing you some stuff that I sort of learned this when I was in middle school. I had a good 7th grade class, and this is how I learned to do greatest common factor and lowest common multiple. So first I want to remind you what these words mean. Factors. So factors of 12, just to have some reference here. Factors of 12. Factors are fit inside, and factors are finite. Okay, so little like alliteration. Factors of 12, we have 1 and 12, 2 and 6, 3 and 4. And multiples of 12, multiples are infinite. And multiples of 12 would be like 12 times 1, 12 times 2, 12 times 3, 12 times 4. This goes on. And technically 0 counts as a multiple of 12 and a multiple of every single number. You can never divide by 0, but you can say that 0 is a multiple of anything. And that's important just for really divisibility rules. And I'm going to be teaching some divisibility rules today. So that little detail, it's not major, but it's good to know. Okay. So the greatest common factor, I wanted to start to remind you guys of this stuff because maybe you haven't thought about it since middle school. But the greatest common factor is a number that sort of pushes this way. So I'm using these 3 just to start this off. The greatest common factor of 4, 8, and 48 is 4. Okay, we're saying this is the greatest number that fits in to all 3. Okay, factors fit inside. The lowest common multiple is the smallest number that all 3 of these fit into. So that would be 48. And I just wanted to start this off because when I have taught this lesson, there are a lot of tricks that people have learned with other test companies, and I get it. Those things make sense. I can reconcile them, but sometimes people, I don't know, people switch it up. And I think one of the reasons is maybe because this word's great and this word's lowest and people reverse it, or I just want to illustrate that like this number cannot be, if it fits into all of them, it has to be smaller than the smallest. And this number has to be, at least as big. Okay, this number cannot be smaller than the biggest. This number cannot be bigger than the smallest. That's what I'm trying to say. Okay, so the greatest common factor of 12, 18, and 30. If I'm trying to find that, you would start with the prime factorization. And since you're saying the greatest amount of stuff in common, what I'm looking at is I see that a 2 goes through all of them, and I see that a 3 goes through all of them. And therefore, the greatest common factor of 12, 18, and 30 is going to be 2 times 3, okay, or 6. I wanted to start off with numbers that were easy enough that you could be like, yeah, that makes sense. And then I'm going to dial it up with harder numbers and things that, you might be more something you'd see on the test. Okay, The lowest common multiple of these numbers is, the way I think about it is, sometimes I call it like the mama caterpillar. And I'm trying to make a number that all of these numbers fit into. And sometimes I make that number on the fly. Okay. So what I was saying over here, when you have multiples of 12, all of these numbers that are multiples, like if I said 36, that's 2 times 2 times 3 times 3. This is 2 times 2 times 3 times 5. To be a multiple of 12, you need to have the pieces of 12 inside. So to be a multiple of 12, 18, and 30, I need to have the pieces of 12 inside. I need to have the pieces of 18 inside. I need to have the pieces of 30 inside. But this mama caterpillar doesn't want to carry extra weight, and she doesn't want to be bigger. She wants to be the lowest thing that fits all of these numbers in. So one way, I mean, I would just start, I usually would say start with the longest chain you have. But right here, all of my caterpillars are equal size. They're all 3 circles long. So what I will do is just start with 12, and I'll put a 2 times a 2 times a 3. Okay, so 12 is taken care of. Now I'm going to go to 18. 18 requires that there's a single 2 in there, which I have, and it requires that I have 2 3s. I have 1 3, so I need to put a second 3. Now 18 is taken care of. 30 requires a 2, a 3, and a 5. I have the 2 and the 3. I need a 5. Get rid of this circle. Okay, and now all these things are represented in here. So I have the 2 3s, I have the 5, and the 2 2s. And then another thing I want to say is that when you're multiplying numbers, you should always look for any 2 times 5. This test, or both of these tests, really emphasize the fact that we work in a base 10 system, okay, powers of 10. And 2 times 5 is 10, so I'm going to start with that. That's 10, and then I cross that off. This is 18. So the lowest common multiple of 12, 18, and 30 is 180. Okay, that is the smallest number that they all fit inside. Okay. Moving, we're going to come back to this concept. And again, if you have any questions, please throw them out there, because sometimes questions help me just, see where everyone is and, like, speak up for probably what other people might not be getting. Okay, let's say I ask, find all the factors of 180, the number we just saw. And I always tell my students, like, some buzzwords for number caterpillars are like factor, divisor, multiples, divisible, anything to do with primes, integers, and also a lot of roots and exponents problems really require the knowledge of breaking down things into their prime factorization. Okay, so find all the factors of 180. I'm going to do this outside-inside method. The first thing is, because I'm talking about 180, what I want to do is I want to look at its prime factorization, its number caterpillar. 180, 18 times 10. 10 is 2 times 5. 18 is 2 times 9. So 2 times 3 times 3. Okay, that's just sometimes how I do it on the fly. You can use factor trees if you want. That's when you're doing this. A lot of my students ask, how I do this quickly, and it's just because I've been doing it for ages. But everyone gets better when they work on this over and over. And it's what sometimes a thing that I make students do is do the prime factorization of numbers under 100 over and over, divisibility over and over, so that they see this really clearly, and it changes things pretty rapidly or pretty significantly. Okay, so back to this. If I'm doing the dividing 180, I'm going to start with 180, 2 goes into 18 9 times, so 2 and 90, 3 goes into 18 6 times, 3 and 60. And then I asked my students, does 4 go into 180? And you guys can all think about that for a second. Okay, And right about here, usually when I'm watching students, what I see is I usually see like my students will kind of like look up to one side, and I always know at that point that they're doing division. And, whether they figure it out or not, I know it's division and I want to show you something else. I look at it like this. Yeah, I know 4 goes into 180 because I see 2 times 2. Okay. The caterpillar for 4 is 2 times 2. And if I want to figure out how many times 4 goes into 180, I'm going to look at the other ones that I haven't checked. 5 times 3 times 3. So 5 times 3 times 3 is 45. And that's how many times 4 goes into 180. Then 5. Does 5 go into 180? Yeah, obviously. Okay, 5 goes in, but how many times? You're going to multiply this times this times this times this, which is 4 times 9 or 36. 5 goes in 36 times. Okay, then 6. 6 goes, it should be an easy one because 6 goes into 18 3 times, and it's going to go into 180 30 times. Okay, 7. Let me write these right here. 7, 11. These are different elements of the periodic table. So different prime numbers, with that are indivisible, that have their own colors. I'm just going to put them over here. So 7 does not go into 180. Why? Because I don't see that color represented in the chain. Okay. 8. Does 8 go in? No, but kind of a different reason. 8 is 2 times 2 times 2. So 8 doesn't go into 180 because there's not enough 2's. And sometimes a question might ask something like 180x is divisible by 8. What is the smallest integer value of x? And based off this, you could see that it would be 2, okay? Because I need one more 2 to make this work and this to turn into 1 and have no prime numbers on the bottom. That's kind of another definition of divisibility. When you're able to make sure that all the prime numbers in the denominator cancel out with the prime numbers on the top. Okay, so 7, 8, 9 goes into 180 20 times, 10 goes into 180 18 times, 11 does not go in for the same reason 7 doesn't go in. 12 is 2 times 2 times 3. 12 goes in 15 times. 13 doesn't go in because for the same reason. 14 doesn't go in because it needs a 7. I've closed the gap. And now I have all factors of 180. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 times 2. There are 18 positive, unique factors of 180. Okay, there's 18 positive, unique factors. There are 3 distinct prime factors, 2, 3, and 5. Okay. And I'm saying this also because as much as you always have to use the caterpillar, I think there's only one problem in my life that I can even think of, maybe 2, where I've ever seen the question actually be about the caterpillar or about the prime factorization. There's never an answer that someone's going to say there's 5 factors. When I say never, I mean, like, yeah, I mean, this is all about, this is how you look at it. And the way I think about it is like a number caterpillar. It's like taking an x-ray of a number and being able to sort of understand the patterns that make the number. Okay. Okay. Moving along, we're going to go to rules of divisibility. Oh, wait, hold on. Sorry. Before we even go any further, I forgot. I had a follow-up question. 72, 60, and 96. I'd like you guys to take a minute. This is like using what we've just learned. Okay. And I would like you to find the greatest common factor and the lowest common multiple of these 3 numbers. And if you don't know what to do, just start by caterpillaring all these numbers. Okay. So that you can follow along when we do go through it. And I'll give you like a little hint that the greatest common factor, remind you that it has to be like less than 60, or it has to be no bigger than 60, but it is less than 50. And the lowest common multiple would have to be at least as big as 96, but I'll tell you that it's between 1,000 and 2,000. So why don't you guys work on that for a minute? And when you're done, just put done in the chat so I can, I'm gonna wait for about like 3 or 4 dones before I go ahead. Okay, can we go back to how we do caterpillars? The idea caterpillars is prime factorization. So if you know how to do factor trees, what you're doing is dividing numbers. So I'll do a caterpillar here. If I were doing, say, 48, I might go 2 and 24. This is a prime number, circle it. 24 is 2 times 12. 12 is 2 times 6, 2 times 3. So the caterpillar for 48 is 2 times 2 times 2 times 2 times 3. If you want to be fancy, you can say it's 2 to the 4th, 3 to the 1st. But right now I'm just doing this long visual of doing it sort of, I want it visual before people start getting to buy the book and mathy, because this is how I see it. I don't, it's easier for me to see the 2 to the 4th, 3 to the 1. Whenever I give these things, it's a little hard for me. I always like to do private tutoring over. I like to be in a classroom teacher. It was definitely my thing, but when I never really liked teaching classes online because I always feel like I'm talking to myself and I don't know where anyone is. So if you guys like want to chime in, please feel free, because that's sort of, how I get my feedback. Okay, we got a couple people done, so I'm gonna get started. 72. Prime factorization for 72 is 2 times 2 times 2 times 3 times 3. 60 is 2 times 2 times 3 times 5. 96 is, there should have been 5 2s and 1 3. Okay, these are the prime factorizations for each of these numbers. So if I want the greatest common factor of these 70, if I wasn't clear, let me just say this again. I'm trying to get the greatest common factor of all 3 of them. The greatest common factor of 72, 60, and 96. To put this in context, where you might have seen something like this in high school, is, let's just say I had like 72x plus 60y plus 96z, and you had to take the greatest common factor out. What's the biggest number that goes into all of them? That's kind of what we're doing. But the concepts you see on this test are going to be a lot more complicated in different questions. I'll throw some of those out when I get through the entire lesson. So you can just see where this goes eventually, or what the potential is. But the greatest common factor is that I have a 2 in all of them, or I have 2 2s in all of them, and I have 1 3 in all of them. So the greatest common factor, this looks a little bit messy. The greatest common factor of this is 2 times 2 times 3, or 12. Okay. In other words, I could take a 12 out of all of them and leave behind 6x plus 5y plus 8z. Okay. Okay. Lowest common multiple. The lowest common multiple is a number that all 3 have to fit into. So starting with 96, look at 96, that you have to have 5 2s. So my number has to have 5 2s. Okay. And it has to have 5 2s for 96 to fit in. It also has to have a 3 for 96 to fit in. 72 needs to have 3 2s. I have that. Needs 2 3s, so I need to add a 3. And 50 needs to have a 5. So I have to have 5 2s, 2 3s, and 1 5. Okay. And that's that's double the number, Suraj, but at least you're on the right track. There's 5 2s. I think somehow you got 6 2s in there. 2 times 5 is 10. So I'm going to take one of those off. This is just how I would do it. I'm thinking about it like 2 times 5 times 2. That's my 10. And then I have to do 16 times 9. Okay. So 16 times 9 is 9 times 10 and 9 times 6. Put that together. I have 144. So here's my lowest common multiple, 1440. Okay. Over here, I want to tell you that in the beginning, my first couple lessons, I teach people how to do long division and multiplication. And let me talk a little bit about double digit multiplication. If I had a number like 23 times 17, I show my students to do this 2 by 2 box. And this 2 by 2 box, I use it a lot. I use it for quadratic factoring. It's really important because it also shows you, like, there's a lot of problems that have to do with patterns in units, digits, and patterns and remainders. And I want to show you this to illustrate this. But if I was doing 23, I would change it to 20 and 3 and 10 and 7. And I'm going to go 10 times 20 is 200. 10 times 3 is 30. 7 times 20 is 140. And 7 times 3 is 21. And then I'm going to add up all these pieces. And before I do that, I just want to say, like, this also illustrates that you can see that the units digit of this number is only coming from this box right here, this bottom right. So that's important because sometimes when I'm doing a problem very quickly and I don't want to do the whole thing, I'm like, well, I know the number ends in 1. And maybe there only is one result that ends in 1. And I've done that a lot where students are like, ooh, I forgot that trick. So anyway, back here, this is going to be 200. 170 and 21, and I have 391. Okay. I bring this up too because I have this like concept or this term that I always use, this that I say, like, edges of the universe. Like, how do you know if that's something that you really need to know or if that's too hard? These tests, the GRE and the GMAT, both of them really don't expect you to do like a lot of heavy lifting, a lot of brute force multiplication. If you have you should be able to pretty easily do a 3-digit number times a 1-digit number in the same sort of way. I would go 8 times 300 is that. 8 times 20 is 160. 8 times 7 is 56. And I would add that up. Okay. That should be required of you. A 3 by 1. Also a 2 by 2. But if you ever have a 3-digit number times a 2-digit number and you're trying to do this, you're probably doing something wrong. And that's beyond the edges of the universe. And that's like an important concept to know. I mean, there are definitely things on the GRE where you should use a calculator, but they are few and far between. And sometimes it's important to understand this. If you did it in your head and you can do it very fast, that's fine. There are other numbers that, might be harder and you can use the squares. It's up to you. If you're doing this really quickly, props. That's impressive. I will use it sometimes. I show people how to factor this way. And there's some things that I would use this for, like when I teach long division, I have another concept, but no, you're fine. Okay, so back here, we were going over the lowest common multiple. What else do I want to teach you? Let me teach a little long division the way I do it. This is a little bit trickier and a little harder to sell to students in the beginning, but I have had some students who are like, I'm just going to do it my way. And then by the 4th or 5th lesson, they're like, oh, your way does make a lot more sense. Okay, so let's say if I were doing a number like, let me start with an easy one. The number 91. I always tell my students 91 is my favorite number. 91 is my favorite number because 91 is the only number under 100 that doesn't work for any of my divisibility rules. And a lot of people think it's a prime number, but 91 is divisible by 7. Okay. So this is how I learned this way to do this in graduate school from one of my professors who taught the elementary teachers. I did my master's in math education for high school, but this is a way that he taught elementary teachers how to teach long division. And when I saw it, I was like, oh, this makes so much more sense because this is how I really do things in my head. But I didn't ever do it with 3-digit divided by 2-digit or anything bigger. So if I were doing 91 divided by 70, by 7, my head, I would be thinking, okay, like I know that 7 goes into 70. And I know that it goes into 70 10 times. And then 21 is left over, and 7 goes into 21 3 times. So I can see that 7 goes into 91 13 times. Okay, that's the method. If I'm doing bigger numbers, like the number 1002 divided by 6, I still use the same thing. And just to compare it with the way that we've learned before, so that you could see it side by side and realize that I'm not doing something crazy different. Okay, I know that normally we'd go like 6 goes into 10 once. That's what you're doing. I'm sort of saying the same thing, but I'm just going 600. And over here, I'm going to go 6 goes into 600 100 times. And then I'm going to subtract and see that's 402. I also like to do no-brainer numbers that end in zeros so that the subtraction is really easy. Now, here's like why this way kind of gets screwed up is, let's say you do something like, I don't know, you just have like a blip and you're not thinking, and you put the wrong thing like 30 and you put a 5 up here, then you're going to mess everything up. Here, if you do that and you're going really fast and you say, well, I know that 6 goes into 30, so I know it goes into 350 times, you won't get screwed up. You subtract, you get 102, 6 goes into this, I could say 60 times, it goes into 60 10 times, then 42. Again, you might not remember that 6 goes into 42 7 times. If you do, great. So no matter what, as long as you do this part right and subtraction right, it will work out no matter how you do it. So I took an extra step because I could have put 360 right here, but it still comes out to 167 no matter how I cut it. Okay, so that's one thing I teach. A lot of the things I have to teach are like little tricks on how to make less mistakes, or certain things that are really more arithmetic. I do a lot of things where I teach students, like I would say my favorite word is factoring. And sometimes students will go, so I distributed. And I'm like, no, distributing is not a good word. We always want to, you always want to kind of cut things up. That's really what this is all about. Like reducing the numbers, simplifying, looking at the patterns, crossing things out. You really only multiply at the end. Okay, so back to where I was going before. We're going to do rules of divisibility, and I'm going to show you some tricks with this. Okay, starting off with the ones that I hope everyone does know. The ones that have to do with units, digits. Okay, 2. You know that 2 goes into a number if the number is even. Okay, you know 5 goes into a number if the number ends in 0 or 5. And then 10. Okay, the number ends in 0. Okay. I just also want to explain where we're going. And I want to do it like this because I want to explain that these are the ones that have to do with units, digits. Because what's going on a little bit is when I teach patterns with the patterns and remainders, which is like a complicated lesson, people get it a lot confused. People keep trying to do the units, digits with the other problems. And these are the only numbers that you can think about when you're talking about units, digits. Okay, so the 3 trick. How can you tell if 3 goes into a number? This is really the most important trick. When I was a trig and calc teacher, I made sure that my students always knew this, because sometimes they would not reduce their fractions, and I would tell them, like, I only have one answer key, and I'm not going to be trying to figure out if your fraction is equal to my fraction. So 3, the number 3 goes into a number when the sum of the digits is divisible by 3. Okay. Here's a good problem for this. How many prime numbers, how many integers between 50 and 70 are prime? Okay. So what I'm going to do is I'm going to start by writing out all the odd numbers between 50 and 70. Prime numbers are always odd except for the number 2. 2 is the lone even prime number. And that comes up when I talk about odds and evens. But 51, 53, 55, 57, 59, 61, 63, 65, 67, 69. I like to put these 10 out here and then cross off the obvious ones. We know that 55 and 65 are not prime numbers. Hopefully we can remember that 63 is divisible by it's 7 times 9. I'd get rid of that one. Okay, this is where the 3 trick comes in handy. So what we're gonna do, you take 51, you add these two numbers, 5 plus 1, you add these two digits, I should say. 5 plus 1 is 6. 6 is divisible by 3. Therefore, 51 is not a prime number. Okay, I'm gonna put it over here. 5 plus 3 is 8. 8 is not divisible by 3. Therefore, this is prime. 5 plus 7 is 12. 12 is divisible by 3. Therefore, not prime. 5 plus 9 is 14. 14 is not divisible by 3. Prime. 6 plus 1, 7, not divisible by 3. Prime. 6 plus 7, 13, not divisible by 3. Prime. 6 plus 9 is 15. 15 is divisible by 3, not prime. Okay? So because the digits of these all add up to multiples of 3, you know that they are divisible by 3. Okay? And then I'm going to do that long division the way I showed you. Okay, so I go, oh, 3 goes into 30, 21 left over goes into 21. So 3 goes into 30 10 times, 3 goes into 21 7 times. So 51, the caterpillar for 51 is 3 times 17. Okay. When my students, this is really the most important trick for doing the caterpillar chart that I teach, because basically when you look at this, okay, looking at this, look at 3, it shows up every third number. Okay. So the 3 trick's super important because 33% of numbers are divisible by 3. And the 3 trick will get you for every single weird looking odd number. And when I say weird looking, I mean I don't think 49 should be a weird looking number. Hopefully you know that 49 is 7 times 7. If you kind of have, your multiplication tables down, you would hopefully recognize it. I think anything, obviously, that's divisible by 11, you would know. 22, 33, 44, those things. But 51's a weird one. I mean, this is one, back to my 7th grade class, but I remember my math teacher used to say his favorite number was 51 because he liked to put like 51 over 6 on a test to see if we would, know to reduce it. So when I was telling you the 3 trick is going to work for every single weird looking number under 100 except for 91. That's why I make 91 my favorite number, because I want my students, I don't know why this always happens with this thing, but it drives me crazy. I want people to know that, no, I'm obsessed about it. Okay. I want my students to know that 91, and there is a rule of divisibility for 7. There's a rule of divisibility for every single integer. They could just be super random and not worth knowing. But I consider them outside the edges of the universe. So I don't really want my students to learn that trick. I just want them to remember 91. Okay. That's the whole point of what I was saying about 91. Okay. The 9 trick. Okay. The 9 trick is like the 3 trick, and that should make sense because 9 is 3 times 3 and they're closely related. So the 9 trick is that the sum of the digits is divisible by 9. Okay. So those 2 tricks work the same. Another one that I use, sometimes I like this one. Okay. What is the remainder? I'll let you guys try this. What is the remainder when, let me find my problem. What is the remainder when 237,941,386? What is the remainder when this number is divided by 9? Okay. Why don't you guys think about that for a second? If you have any ideas, throw it in there. And then after this, while you're working this, we're going to do Okay, again, the question is, what's the remainder when that number, 237,941,386 is divided by 9? That is correct. Okay. One thing you could do is you could add up all the digits. This is a little thing that I thought of. I always say that I made this up when I was in high school or whenever. At some point, I came up with a better way of doing it. Instead of adding all the digits, by the way, if you add the digits, you get 43. And if you get 43 and you divide it by 9, you'll get a remainder of 7. But another way that I do it is I don't actually add them all up. I just knock them off 9 at a time, because when you do that, you are knocking off a multiple of 9. So I would say like 9, then maybe 2 plus 7 is 9. 8 plus 1 is 9. 6 plus 3 is 9. And I'm left with a 4 and a 3. So it's 7 more than a multiple of 9. And people are like, sometimes people go like, I don't get how that works if like that's in this place value and that place value. And quite honestly, the first time I did it, I wasn't really sure. So what I did was I tested it, and I took a number that was, my hypothesis that it's 7 more than a multiple of 9. So I just took this number, the original number, I subtracted 7 from it, which is 379. And then I did the trick again. So knock off 9, 2 and 7 is another 9. 9 right here, and then I have 3, 4, 1, 3, and 7. This is 10. This is 8. 18 is divisible by 9. So obviously this is divisible by 9. And therefore, yeah, answer is 7. Okay. Okay. The 4 trick. This, by the way, let me get rid of this. I would say that this is a little bit of magic. Okay. I don't know why this works, or I'm not really going to get into it, but like, it's magic. The 4 trick, it's not magic. I can explain it, maybe just because I don't want them to get confused. Okay, so the 4 trick, first let me say what it is. The last 2 digits form a 2-digit number. I know this is repetitive, but I want to make it clear. The last 2 digits form a 2-digit number, a 2-digit number that's a multiple of 4. Okay, the last 2 digits are a number that is divisible by 4. That's another way to say it. So let's look at this number, 2,348, okay? What I'm doing is just looking, 2,348. I'm looking at the last 2 digits and I'm saying, does 4 go into this number? Yes, it does. Therefore, 4 goes into the whole thing. Why does this work? Because 4 goes into 100. 25 times. Hopefully that seems easy for everyone. Everyone knows that. So it's sort of like I can look at this number and think of as it 2,300 plus 48. And I know that 4 is going to go into this. It's going to go into 100. It's going to go into 2,300. It's going to go into any multiple of 100. And then what I'm really doing is just looking at the leftovers. Does 4 go into the leftovers? Here it does. Therefore, I know that 4 goes into the whole thing. Okay, so that's how the 4th trick works. Sometimes people go, I'm going to divide it by 2 twice, and that's not practical. Okay, that's going to take too long. But there are so many problems that we will do, like, that when we work on, when we want to do units digits, and you want to know what the remainder is when the number is divisible by 4. There are problems that say, like, what is the units digit of 7 to the 2, 3, 1, okay? And really, it cycles in 4. And what I would really want to do is figure out what's the remainder when 231 is divided by 4. And really, that's the same thing as asking what's the remainder when 31 is divisible by 4, which is a remainder of 3. And from that, I would get it. So this is why I need these divisibility rules. The 8 trick, I'm going to straight up say I barely ever use it. I like just, pay it some lip service because there's some sort of like, there's a symmetry that I really like when I teach roots and when I teach fraction to decimals, but this is just the last 3 digits. Right? The last 3 digits are divisible by 8. Okay, this is because 8 does not go into 100, but it does go into 1,000. Okay, 100 divided by 8 is 12.5. 1,000 divided by 8 is 125. Okay, I think I used it for the first time the other day. I found a problem and I was like, wow, I actually used it once. Okay, 6. 6 I do with a different color because 6 is not a new trick. 6 is going back to the caterpillars, okay? Here's the caterpillar for 6. It's 2 times 3. So when you want to know if a number is divisible by 6, you're really just asking, is the number even, okay? And is a number divisible by 3? So it's the 2 trick and the 3 trick together. Okay, I already did this number before, but the number 1002, when I did long division for this, I'd look at this number, I see that it's even, I add up the digits, I see that the digits add up to a multiple of 3, so I know that this number is divisible by 6, and this is where I did this one, and I got 167 before, because I did 600, 402, 360, 42, okay, 167. Okay, now the 11 trick. And this is where like a lot of people do learn this with the company and they don't think they need it, but you do. The 11 trick is important, okay? So the 11 trick, I want to say like I did learn all of these and again, that 7th grade class, I never learned the 8 trick and I definitely didn't learn the 11 trick, but I used these all through my time in high school. I wasn't allowed to use a calculator in high school until I got to trigonometry. So I feel like these things they're kind of a little bit like learning your multiplication tables because they help you break down numbers faster. It's a really important part of like being very quick with arithmetic. And that's what I'm trying to stress. Sorry. How did I know it's a cycle of 4? I know that because when I get it, that's like something that I teach in my 3rd lesson, but it's something, I mean, I know it, but I'm just saying that like it's something that yeah, when I do patterns and remainders with Unistitch, it's a little bit higher level and I wouldn't throw it into this class because I need to hear what people's questions are. And I usually have to do that one-on-one. But there's a bunch that cycle in 4s and some that cycle in 2s and some that don't cycle at all. Okay, the 11 trick. I'm going to alternate positive and negative signs on the digits. Hold on. Alternate positive and negative signs on each digit. Sum together. See if the result is a multiple of 11. But remember, 0 counts. And this is important because with the 11, really common that it is 0. Okay, so look here. If I have the number 187, I'm going to go plus, minus, plus, meaning positive 1, minus 8, positive 7. Box the term and the sign in front. I just encourage this so that your eyes don't play tricks on you. That is 8 minus 8, which is 0. 0 is a multiple of 11. Therefore, 187 is divisible by 11. Okay, 11 goes into this number, or 11 goes into 110, 10 times. Do subtraction, I get 77. 11 goes into 77, 7 times. So this is what I'm seeing. 187 is 11 times 17. Okay, that's how the 11 trick works. Okay, here's another one. 946. Plus, minus, plus. Okay, so 9 minus 4 plus 6 gives me 15 minus 4, which is 11. This is a rare one. They're usually 0. It took me, I don't know, I had to like reverse engineer and think how this was going to work. But 946 divided by 11. I know that 88, 11 goes into 88. I'm just putting a 0 on it. So here's another way. Sometimes when people don't like this in the beginning, I'm like, you would normally put 88 here. So I'm telling you, just put the 8 over here, then put a 0, put a 0. I subtract 6, 11 goes into 66, 6 times. Okay, so 946 is 11 times 86. This is prime. 86 is divisible by 2 times 43. 43 is a weird looking odd number. Does 3 go into it? No, because 4 plus 3 is 7. That's not, so that's how I know it's prime. Okay. Okay, that's a caterpillar for 200 for 946. 2 times 11 times 43. Okay, now we're going to use these for a problem. Which of the following is divisible by 36? Okay, which of the following numbers is divisible by 36? 5,232, 5,742, 5,244, 5,364, or 5,130. Okay, just to get you started, see that word divisible? This tells me that caterpillars are involved. So I can't caterpillar all these. That's going to take forever. That's going to, as long as just doing long division. So you're going to caterpillar 36 and think about what 36 is. And why don't you do that? And that's going to be how you can think about this number. I'll give you guys 2 minutes to work on it. If you get the answer, just put done in the notes. Or if you think you get an answer, put done. And then I'll go through it. Choice. Okay. Okay. Some hot shots here. Okay, so let's see. What's divisible by 36? 36 is 2 times 2 times 3 times 3. Okay, so sometimes people go, oh, I'm going to use the 6 trick. And the 6 trick is 2 times 3. And all these numbers are even, so all of them are divisible by 2. And if we do the 3 trick and we add up all these, we're going to see that this adds up to 12. This adds up to 18. This adds up to 15. This adds up to 18. And this adds up to 9. And just quick look here, all of these are divisible by 3. So all of these are divisible by 6. But the question doesn't ask you which is divisible by, which of the following is divisible by 6. It asks 36. So how's that problem different? And that's where we're going to use some of the tricks that I just taught you. If something is divisible by 6, then it has to be divisible by 4. And it also has to be divisible by 9. Okay. So looking here, I would say, okay, this is not, 12 is not divisible by 9. 18 is, 15 is not divisible by 9. 18 is again, 9 is. Okay, so these are left standing. Then what about 4? Okay, this 42 is not divisible by 4, so that one's out. 64 is, 30 is not. So here's my final answer. Okay, D is the only thing that is divisible by both 4 and 9. Other variations of this problem, sometimes they'll say, like, what's divisible by 12? Okay, and if you're trying to figure out if something's divisible by 12, you're really trying to figure out, does it have 2 2s and a 3 in it? And you might use the trick for 4 and the trick for 3. You want the tricks not to overlap. They should be like mutually exclusive. 18 is another popular one. You would, if 18 is divisible by 3 times 3 times 2, so you want to use the 9 trick, and then you want to make sure that the number is also even. But you could do it for, I mean, like if I had to try to figure out if something was divisible by 88, okay, I would be going 2 times 2 times 2 and 11. I would use the 11 trick, and then I'd use that 8 trick that I've never used, okay? but I have problems that I'm gonna do where I make that. Okay, so this is a little bit of sample of some of the stuff that I always have to start in the very beginning. After this, I teach some other things like how to figure out how many factors are a number. It's kind of a trickier concept, but I said I was going to do some harder problems that have this concept. So these are some that I made up that I'm going to throw out for people who want something a little bit challenging here. Okay, here's some clues. 4 is the greatest common factor of X and 20. That's your first clue or given piece of information. 6 is the greatest common factor of X and 18. And I'm going to make this like a GRE style question, which just means that you could, on the GMAT, there's, like multiple choice and only one answer choice. And GRE says like, you'll see. Which of the following can be values of X? Okay, so 12, 24, 36, 48, and 60. Okay, what I was saying about it being a GRE is that there's more than one answer choice possible. Okay, so you're trying to figure out which of these 5 answers, how many of them could be X based on those clues. This one, if you guys want to chime in and tell me what you think your answers are, go ahead. I disagree with that, Suraj. Not totally either. It doesn't have to be lower than 18. That is incorrect too. Wait, I'm losing track of which ones are right and wrong. That one's right. That's nice, Igor. Okay. All right, here's what I get out of this. So here's 20. Okay. 4 is the greatest common factor of X and 20. So I'm building X. Here's 20. Here's 18. 2 times 2 times 5. 2 times 3 times 3. All right, let me color code this too. Okay, so if I say 4 is the greatest common factor of X and 20, what that tells me is that X has 2 2s in it. It's the greatest common factor. But also what I just learned is that X does not have a 5. Because if X did have a 5, I wouldn't have said 4 is the greatest common factor. Okay, so I know that X has no 5. So right away, that gets rid of 60. Okay, because 60 has a 5 in it. Okay, the other clue was that 6 is the greatest common factor. Let's get rid of this for a sec. Okay, and also I know that X definitely has 2 2s for sure. 6 is the greatest common factor of X and 18. So I'm sorry, X has a 3 and a 2, but it only has 1 3. So no more 3s. Okay, no more 3s. 1 3 max. This number has 2 3s. So 36 is out. Now, here's the deal. X has to have 2 2s and a 3. And then the rest is really, you can put anything you want as long as you never put a 5 and another 3 in there. You could put 17, you could put more you can put more 2s. You just can't, you can put, you can put as many 2s as you want. You just can't add a 5 or a 3 to the chain, and every other thing will work. Okay. So, yeah, that's that one. Okay. I was gonna say I have another problem, but I don't know if it's a little bit insane, so maybe I just will like let that off. Okay, I think I'm gonna wrap it up here because I don't want, I don't know how, I think I'm sometimes I make things a little bit insanely hard, but I'm gonna leave this off and just let you guys know, right now I am starting to take people for, deferred enrollment if you're looking and if you're a senior and you're taking people, or if you're doing the April test. I also am starting to work with people who are doing round 1 next year, or people who are doing round 3. There's usually fewer of them. For people who are doing round 2, I mean, this is really would be a very late start. So if you are thinking that and you're looking into that, I can talk about it, but it's a little bit stressful to be starting that right now. It all depends on the situation. I did have someone who said that they wanted to take the test in a month, and that's the person I put up in the beginning. And when I first heard her say that, I thought she was, kind of just didn't know what she was talking about, but she did, and we got it done, and she got a 705, which is like a 750 on the classic, so great score. But it all depends on, I did actually start with 2 people a week ago, but both of them were very strong. Anyway, I would urge you guys, if anyone is thinking about doing this for next year, just start right away. Okay. I would, and if you guys have any questions, please feel free to message me on the Leland app, and I will be happy to answer your questions and kind of get you straightened out. Applying in 20, that's smart. Just do that now. But even the person I'm just telling you, like the person who I just got ready, the person Elizabeth, she graduated college this year. She's starting a job, or she'd started a job about 2 weeks ago, and she just wanted to have this test so that she could have it for the next 5 years. So she was just, some people, I always say, like, even if you're thinking about doing this next year, the best advice I could give is really just do it, get it over with, get it started with. And also because everyone always thinks that they have more time than they have. Okay. They always, and don't think, like, I would say that it takes 3 to 6 months, and you don't know where you are on that end of the spectrum. And with someone, even the person Elizabeth, who did do very well, she took the first test and got like the lowest score she'd ever seen. And then 16 days later got the 705, which was awesome. So, I the best advice I can give is to just not stress yourself out and find, just figure it out. Maybe we could talk about it, and then I would let you know from there. Okay. I'm glad you guys enjoyed the class. Please reach out if you have any other questions, and if I can do anything to set you up for success, would be very happy to. Thank you. Take care.